Okay, we're now going to look at problem 3, workshop 9, the math 2303. This, I'm going to go to the whiteboard again, explain a few things as we go along. And so the problem number 3 asks us to find the inverse Laplace transform. So if we get capital F of S equal to e to the minus 4s, 1 over s to the 4th, plus 2 over s squared. I like to write that, get it into the proper form. And so I will write it as this, e to the minus 4s. So I can use the formulas that I know. I have 1/6 here, 3 factorial over s to the 4th. And so that's going to give us a t cubed, 1/6 t cubed. Here I get plus 2 times 1 over s squared. And so this will give me 1/6. And because we have an e to the minus 4s, we have the 3 factorial over s to the 4th would give us a t cubed. So this would be a t cubed type, 1/6 t cubed. But because we have that there, we have 1/6. So it shifted t minus 4 cubed. And then for the second term here, we have plus 2 t minus 4, because this would just give us t. And we have times u of t minus 4. Okay, that has used the formula that the Laplace transform of t minus a f of t minus a times e to the minus times u of t minus a is equal to capital F of S e to the minus as. So we have used that. You'll notice that we make these line up properly. And so here's where I've done that. That lines up over here. And also that one lines up. Okay, so there's how we use that formula. B part, so that was A part, by the way. B part has g of s, and so by the way, so up here this is f of t, then the Laplace transform, inverse Laplace transform, capital F of s. Let's get the notation used properly. Second part, we have g of s equal to e to the minus 2s times s squared plus s plus 1 over s minus 1 s squared plus 2. I use the partial fractions to make that simpler. And so we will have here e to the minus 2s. And using the partial fractions, I won't do that part. We have 1 over s minus 1. And we have 1 over s squared plus 2. And so Okay, so we have that expression. And so just to give us a little hand on e to the minus 2s, I'm going to be able to handle s minus 1 nicely, but I would like to see, this is a sign. So what do I need up here? I need a root 2 to go with the s squared plus 2. So I adjust it with a 1 over root 2 there. And that gives me equal to, so g of t then, looking at this, is, so this part here would be e to the t, but I have a shift here, so it's e to the t minus 2. And here I have plus 1 over root 2, and this would be the sine of root 2 times t, but because of the shift here again, because of the exponential, we're going to be shifting this. This is a t minus 2, and then I have all of this times u of t minus 2. So I've used the formula that I'm pointing out right here again in this problem. So that finishes 3a and b. I think I'll stop the video now and solve the last problem on the next video. So